Hi, everybody, and welcome to our November webinar from the Agriculture, Food Systems and Bioeconomy Research Centre of the Rhine Institute here in the University of Galway. My name is Mullen. I'm a lecturer in nutrition security and sustainable food systems, and I'm absolutely delighted to introduce our speaker today, Professor Claire Heffernan. So Claire is a Professor of International Development at the Royal Veterinary College in London. Claire is a veterinarian with social science training. I've known Claire a little over the past few years and have been an avid follower of her work, because Claire's work is, to my mind, a lovely building on research, training, policy support, and capacity strengthening around the world. Claire has a lot of insight into how interdisciplinary, and I even saw the word metadisciplinary, some of these global challenges we face are, and has done a lot of capacity building through the Risk Resilience Hub of the University of Bristol, Livestock Development Group at the University of Reading, the London International Development Centre as well. Claire brings together interdisciplinary research on these grand challenges that we face around climate change and health, antimicrobial resistance, sustainable food systems, and disease emergence. So as well as being an active researcher and trainer and educator, Claire is wonderful at building capacity for interdisciplinary research. And one of the other things I really like about Claire's work is this kind of focus on key issues like fundamental grounded work on poverty and child health. So always bringing it back to people. Claire is going to speak to us today on the interdependence of human and animal health in climate change and globalized food systems. Before I hand over to Claire, it's a couple of housekeeping. We are recording this video. It'll be made available shortly afterwards on the Rhine Institute YouTube channel. To ask questions, please use the chat function. So type your question in. If you would like me to identify your name, type your name in. Otherwise, don't include your name and I'll read out the questions on your behalf. So over to you, Claire, if you'd like to take it away. Thank you.
Many thanks. That was a really kind introduction. Thank you so much, Anne, and a big thank you to the Rhine Institute for inviting me here today to give this seminar. It's absolutely my pleasure. So I thought I would start looking at this quite a big topic by looking at the future. So next slide, please. So everybody now is really focused on this post-2030 agenda. So what we're seeing a real change in the discourse, the development discourse. So it's also called the transformational agenda. So there's talk about climate resilience and justice, recalibrating the global food system, addressing global health and health inequalities, social justice reparations. So the future, there's this really big shift that's happening. And so the focus is on these socio-technological system shifts and on solutions. So that's what we're seeing now in the discourse around the post-2030 agenda. So then the question becomes, well, how does One Health fit into that? So next slide, please. So, oops. So, right, so here's a very old definition of One Health. And if we go back to the definitions, there's no shortage of definitions for One Health. The literature is absolutely riddled with them. So here's a very kind of old one. It recognizes the health of human animals ecosystems are interconnected. Okay, fine. While applying coordinated, collaborative, multidisciplinary. I think today they would use interdisciplinary, cross-sectoral to address, this is the really important bit, potential or existing risks. All right, so you're using One Health. You are describing the different component parts, and we're using it to describe or to aimed at these potential or existing risks. Okay, next slide, please. This is a much more modern definition from kind of 2022. And here we're talking about, again, we're talking about balancing sectors, but we're not really talking about synergies and interactions. And here, the aim of One Health is to foster well-being and threats to health and ecosystems. So again, is that enough? If we have this in mind of what the future is going to be like. So next slide, please. So then I started looking at schematas. So do the schematas, do this kind of interdisciplinary weaving any better? And yeah, okay, there's a very kind of old one from the University of Alaska. And yeah, it's very simple, the three circles, and they're kind of in One Health is kind of in the middle. Next slide, please. This is the very famous One Health umbrella where everything in the kitchen sink is kind of included under that. And then finally, we have kind of the middle one, which is the next slide, please. Which is, okay, this was, you know, a little bit more kind of a combination of both. So this is very kind of recent. You see this kind of schematic a lot in the literature. So next slide, please. So when we look at the literature, all right, this is from 2016. We were involved in a Bill and Melinda Gates project on building a One Health metric. And when we looked at the literature, the vast majority of literature on One Health was on zoonotic diseases, 75% in 2016. Metrics, 1% of papers. Policymaking, again, not very, didn't have any kind of very few papers on policymaking. So next slide, please. So if we go to 2023, all right, we see this emergence of AMR in the literature. So the vast explosion of literature on One Health, but really dominated by zoonotic diseases, but AMR is coming up again. Metrics a little bit, a few more. Policymaking, not really. Okay, next slide, please. So I wanted to talk about One Health challenges. And the first challenge that I'm going to talk about, so this is One Health praxis, was environmental AMR. And I know that some of you will be working environmental AMR, know a lot about it, but I just wanted to kind of present an overview and then one of the projects that we worked on. So environmental AMR, antibiotic pollution, and that includes antibiotic residues, antibiotic resistant bacteria, and their resistant genes or ARGs. They've been detected in all sort of waters and sediment across the world. You see them from the Arctic to Antarctica. There's no escape from environmental AMR. Next slide, please. So not terribly surprising, they arrive in the environment by human and animal waste, manufacturing, disposal of medical waste is another big issue, and agricultural activities, and then they're spread through waterways across the world. They seed in the environment, so resistant genes spread through other bacterial populations. So next slide, please. Now, in this mix, we're going to add in some contaminants of emerging concern. Now, these contaminants of emerging concern are really unable to be removed by wastewater treatment plants. And this slide really wasn't long enough to include all of them. There's many of them, but I just started to put some kind of really the big picture. So we've got industrial and household chemicals. Every time you wash your floor, have a think about that. Pesticides, organic pollutants, pharmaceutical waste, of course, personal care products, sunscreen, deodorant also doesn't get filtered out. And then, of course, we've got the really nefarious, the DDT, the dioxins, food additives, et cetera, et cetera, et cetera. So there's mix in with antibiotic waste, mix that into the contaminants of emerging concern, and you have a very serious public health crisis unfolding. Next slide, please. So if you're interested in environmental AMR, one of the best places on earth is Nairobi, in the Nairobi River. So, you know, it's certainly a dream for AMR researchers, less so for the people residing in the informal settlements. So you have informal settlements on tributaries to the river. You have an industrial area, which has pharmaceutical plants and heavy industry. You have peri-urban agriculture, a lot of that. Got slaughterhouses, commercial dairy poultry farms upriver. And of course, all this leads to a very, very, very heavily polluted environment with industrial waste, heavy metals, agricultural waste, human and animal waste, and just live in the pictures. It's like these rivers are often just a dumping ground. Next slide, please. So it was actually during the pandemic, and we had this, it wasn't a very big project, but it was looking at, we started looking at livestock derived AMR pollution in the Nairobi River. And this was basically in looking at sort of the main arguments that it's livestock AMR that's really driving the environmental AMR issue. So we wanted to look at that. So we had an interdisciplinary team. We had vets, we had agriculture, fish farming specialists, we had water pollution experts, we had chemical experts, and then we had engineers that worked on water filters. And one of the things that we did was we mapped the AMR hotspots. We wanted to identify what the key pollutants are. We engaged in a lot of training and capacity strengthening. And then kind of the final piece of this was like developing these low-cost sustainable water filters. So next slide, please. And of course, we used what's called the source pathway receptor model. And this is from kind of the chemical pollution field of chemical pollution and chemical engineering. And, it does exactly what it says on the tin. It's like you look at all the potential sources, you look at then who is going to be impacted on it, how they're going to, what the pathways are. So you can look at places where you could potentially counteract or address this. So we found it very simple and very easy and very useful framework for this project. Next slide, please. So this is what we found. So this is just the pharmaceuticals, and there were 77 of them. And that was the limit of our testing, and I'm sure there's more. But what we saw was this huge diversity and kind of in the chemicals, from sort of nicotine to codeine to kind of paracetamol to birth control pills to kind of this bisphenol S-butyl phthalate is a plasticizer. And that was very, very, there's a lot of that in the water. But yeah, so it just shows you the kind of like the level of pollutants. Caffeine was also a really big one. Next slide, please. Yeah, so when we looked at the risk quotients for the antibiotics, so clarithromycin and rofloxacin were very big. Metronidazole, sulfadiazole, and sulfamethasone, like trimethoprim sulfa. Now, metronidazole and trimethoprim sulfa are very used in the livestock sector a lot. They're also used in human medicines. So as you can see, like the risk quotient normally is around 1, that far exceeds that in terms of the concentrations of these antibiotics. Next slide, please. And what we found was, and this was really interesting, so lower levels of antibiotics were found in the livestock-related hotspots, so the abattoirs, the commercial farms, aquaculture farms, than in the human hotspots, those the hospitals and the informal settlements. So the antibiotics exceeded the AMR risk ratio in 12% of the livestock hotspots compared to 20% in the human hotspots. So that was, there's a lot more research that needs to be done on this. But it's quite an interesting result. So it shows you that the first immediate focus really needs to, we need to focus on all of it, but like the human health hotspots were very problematic in the Nairobi context. Next slide, please. So one of the things that we did was we built these low-cost water filters, and they were built from banana reiki. And banana reiki is an agricultural waste product. So it's thrown out as part of the it's kind of the branch that the bananas are cut off of. And what we found was these little filters, they reduced 99% of the antibiotic and antibiotic residues from water. And this was a project that occurred during the pandemic. So unfortunately, when we were going to sort of scale up our filters into the field among the informal settlements, so allowing people to have kind of safe drinking water and looking at all the kind of context around technology transfer and what that would mean and how these would be used. Unfortunately, UKRI sort of was taking back money, and most of the people who work in the UK will have been part of this. We're taking back money from research projects. So we had a little tiny bit of money left, with about £36,000, and that was removed from us. So I guess the sort of moral of the story is that timing is everything in research. So we're looking at how to scale these up outside that project. And of course, the GCRF has closed for UKRI, which was a main forum for interdisciplinary work and technology development and transfer. So next slide, please. So my second challenge, my second One Health challenge, is not something that people generally consider to be a One Health challenge, but I'm going to argue that it is. It's the child nutrition nexus. Now, the global food system, our global food system has produced 230 million children under 5 that are wasted, stunted, or clinically obese. But of course, we have to remember that there's all these other things that are happening to these children. 400 million children live in conflict zones. Now, 1 billion children live in geographies that are now classified as extremely vulnerable to climate impacts. So these children today, growing up around the world, face these compound vulnerabilities. Next slide, please. So I want to take you through a little bit about child stunting, which is near and dear to my heart. So low or faltering growth due to chronic malnutrition. There's an operational definition by WHO, which is this height for age has scores, less than 2 standard deviation beating the mean. But stunting isn't just short stature, it's a syndrome. So you have reduced cognitive and neurodevelopment functioning. These children generally suffer from environmental enteric dysfunction, which is one of the key hallmarks, and they have chronic diseases in adulthood. So stunting, poor nutrition or early life really impacts across the life course. So stunted children, a variety of studies have shown they do less well in school, they have lower educational attainment, and that kind of translates to they earn less than their normal peers across their life course. So it's a very serious problem. It's a serious and debilitating problem for children that are impacted by stunting. So if we look at sort of one piece of this, the environmental enteric dysfunction. So next slide, please. So it really is about chronic inflammation of the gut, and it impacts child growth in a variety of different ways. So it reduces digestion and absorption of nutrients. Of course, it has related to systematic inflammation, and a lot of things. It impacts the kind of hunger reflex. These children are less hungry, they eat less, they do less. It's sort of this what's often referred to as a failure to thrive. And what these children, the outcome of that is they have a small intestinal bacterial overgrowth, and the microbiota is seriously impacted. And it's really interesting because some of the studies have shown that sort of Peace Corps volunteers that are going overseas, when they come back and they have EED, the microbiota can kind of recover after a few months. Whereas people who came from these environments, like for example, one of the studies was people that living in rural areas of Thailand, and then they had moved to the States. It took them kind of years for the microbiota to recover. So it seems very much that this is exposure related, and that these drivers can be chronic over time, and children that are exposed at a very young age have very little hope of kind of getting out of this. So the drivers within the literature are this continued exposure to bacteria from feces. So there's this real interplay, again, between poor sanitation wash, micronutrient deficiencies, Heliobacter has a big play in EED, and these environmental toxins. So next slide, please. So here we are, animal source food, livestock keeping, and EED. Now this is starting to emerge. There's a lot more work that needs to be done on this as kind of an issue, because we know there's a variety of different studies that have shown that animal source food has a positive impact on linear growth, and that's particularly related to meat and eggs. But no one really knows how these nutritional benefits are going to be offset by this exposure to zoonotic pathogens. And I felt Chen sent this very well in his paper. We don't know enough about this, and this is a really classic One Health type of issue that we need to kind of, as a sort of theme, or as people working in this area need to. I think it's a really important area that we can contribute to. Okay, next slide, please. So this is my slide on the children and the eggs. So, and this is an example of, I'm going to use an example of India for this. So egg consumption, few studies now, has a positive impact on linear growth. We don't know much about, there's this theory that eggs might have an impact, consumption of eggs might have an impact on the epigenetic signature of stunting. It might provide a protective effect, and we don't know whether that's like during late pregnancy or kind of early or infancy around 6 months when children start to eat eggs, something that the hub's been looking at. But of course, this is countered by both foodborne pathogens and this environmental contamination of backyard and commercial poultry systems. So when we look at India, this is the next slide, please. There's 44 million stunted children, 25 million wasted children, 6 million children that are classified as nutritionally vulnerable after the COVID pandemic. And that's countered by 538 million chickens, and 138 billion eggs. And out of this massive amount of eggs, about 20 billion eggs are consumed in the backyard sector. Produced, I shouldn't say consumed, I should say produced in the backyard sector. Okay, next slide, please. So when we look at kind of figures for egg consumption in India, it's low, but it is rising. So the National Family Health Survey 3, eating eggs was reported by about 5% of households. And by 2019, 2021, it was reported by 17% of households. But vast majority of children in India are classified by WHO as lacking in an appropriately diverse diet. So next slide, please. So all of these commercial chickens live on litter. And what's in this litter? So there's manure, there's feathers and microorganisms, there's dead birds, there's antibiotic residues, there's heavy metal. Across the world, poultry litter is used as a fertilizer for farming. So the runoff enters waterways. And again, and it's not just like, sort of, I could give you an example of India, but it's really like, if you look at the US, I think the Del Mar Peninsula has the highest concentration of poultry farms in the US, and all the surrounding farmland basically uses poultry litter as fertilizer, and the Chesapeake Bay is one of the most polluted waterways globally. So next slide, please. So in India, very similar scenario, you've got large waterways that are used, rivers that are used by a large portion of the population, and you've got working with poultry farms that are commercial poultry farms, in particular cheek and jowl. So we've gone from this big circle from child nutrition to environmental AMR. So that's something to think about in terms of One Health. So, but of course, there's these macro level dynamics. So next slide, please. So there's been a few studies now that study climate change and child nutrition. So this was a study done in 2013, and it found that the timing of birth had a really big impact on nutritional outcomes. So in Niger, if you were born during a drought, you had a 72% chance that you were going to be stunted. Ethiopia, slightly less. And in Kenya, kind of the middle ground, more than half the children. It was a long-term outcome for children that were exposed to floods. And of course, we've got, heat waves, which is there's kind of an emerging literature now that's looking at kind of heat waves and the impact. So we've got a lot of these kind of nutrition climate interactions that are starting to emerge, and they're becoming really important. So at the micro level, we have a lot going on, but at the macro level, when you can track these trends. So the next slide, please. This was work in India again. And so these districts that were classified as highly vulnerable to climate change, the odds of child stunting increased by nearly a third. And the really interesting one was anemia, increased by well over half. So next slide, please. So again, so you're seeing these extremes have a real, so the dry season and wet season extremes have a real impact on child height. So next slide, please. So again, this was work where they were looking at child health, and they created these indexes for child health, and then they mapped that against sort of these high areas of high vulnerability. And if we look at a global level, next slide, please. So this is kind of a UNDP from 2023. This is kind of the highest concentration of children that are stunted. And the next slide, if we go to the next slide, we can see that this is the climate risks in 2040. So you could make predictions based on this modeling. I mean, you can just, visually, you can see that if you put the two maps together, you would be, they would very closely align. So we're seeing that nutrition and climate change are, they're bedfellows. And again, this is a One Health problem. So the next slide, please. So here's another one of my circles. So we've got climate change, right? We know that that directly impacts crop production and the nutritional density of crops. Nutritional density of food impacts infant and child diets. Poor diets and the bioavailability of nutrients impacts child nutrition and child health. Poor child health impacts educational and economic attainment. Low economic attainment is reflected in low GDP. Low GDP countries have suffer the greatest impact of climate change. So here's another big circle. So next slide, please. So I think when we look at One Health, I think I would argue that there's child nutrition, AMR, climate change, food production, they're all inexorably linked. We can't unpack them. But I think our concepts of One Health, by focusing on this kind of inclusivity of trying to be as inclusive as possible, of mapping these disciplines and even problems, we lose a little bit about these synergies and interrelationships. And although we see in the literature, we see the shift away from the dominance of zoonotic diseases, and we see it's still very siloed. So the next slide, please. So I think if we want One Health to contribute to the post-2030 agenda, I think to remain relevant, we need to really look again at these conceptual notions. And I think that we need to move One Health very firmly and strongly into what I term the solution space. And in terms of sort of policy and practice or praxis, I think we want these One Health solutions to drive rather than inform these forthcoming system shifts regarding food and health. So there's an awful lot of work that we have to do. Next slide, please. Now, this is my plea if you please join the Resilience Hub. It's all online. There's a variety of really fantastic talks that go on around all of these issues. And I think my next slide, I just wanted to end with a few. This is my the father of One Health, and he was so prescient and so ahead of his time by looking at these kind of the solution space, as I would argue. And then I think I had one more slide, was just an ending. But thank you very much. It was my pleasure to speak today.
Thank you very much indeed, Claire. That was really, really very interesting, and I'm delighted that you've spoken to us and you've touched on so many topics. For my colleagues, please put questions into the Q&A box or indeed the chat function. I can access both. Claire, I've got quite a lot of questions, but I'm not going to go through them all, I suppose, to begin with. But one I just wanted to start on was, you used a lovely expression about like all the inexorably linked, all these problems, and you said we can't unpack them. And then you moved on to the post-2030 agenda. I just want to ask your opinion about how well do you think the SDGs have encapsulated the ideas that you've expressed around One Health, first of all, and where are we going with the SDGs in the future? Because the recent Global Sustainable Development Report said we need to kind of focus in on thematic areas within the SDGs, and food systems is one. So it's kind of a big question to start, but I'd like to know where you think what you've spoken about, these linked challenges, how they really fit in with the current SDG agenda and where we're going post-2030 on a kind of political level, I suppose.
I think that's a great question. Thank you for that. I think it's kind of, I think the SDGs have been not terribly successful. We know that.
Yeah.
That many are not on target at all. We know that we've seen reversals after the pandemic. And one of the kind of core criticisms of the SDGs is that they live in isolation, and they're not kind of, what we have is, and I normally present on the wicked problem dynamic. We've got wicked and tame problems, and we're treating these very wicked problems as tame problems, right? We treat them as like there's a scientific solution, we can just unpack it. And I think this flows through where we need to be on the post-2030 agenda. And I don't think people have really thought that much about it. They're just talking about transformation for post-2030. They're speaking about, into the discourse is this, that there's this real need to transform. How are we going to make those transformations? that's the question that needs to come up now. And we need to think about that. And I really want people working in the One Health space to really think about these wider interactions of their work. So can One Health be kind of a major player moving forward? Yes. But if we continue to limit One Health, very much how we've limited the SDGs, to these kind of silos, then it will not be as effective as it could be. So yeah, these problems are joined up. We need joined up solutions, and we need to be in the solution space. And I think that's transformative. That's a new way of thinking about this. But that was what I would say. I don't think, these inputs and these discussions need to happen, and they're happening now.
Yeah, thanks, Claire. I'm going to ask a few questions from my colleagues. One is, thanks for this very interesting presentation, Claire. What commonalities does One Health have with planetary health? How can we build bridges between these two agendas? I'm doing some work in planetary health education for medical and environmental practitioners and professionals. So is that question clearer, Claire? Have I expressed?
Yeah, that's absolutely brilliant. And it's funny because I was like, oh, this is going to be too long. I don't want to talk about planetary health. But yeah, planetary health is a really, one of the things that I'm arguing for is we need kind of a health and the kind of metric of how we look at planetary health, and where the lines are, the tipping points. Well, we need that for health. A few years ago, I wrote this kind of paper that not many people read, I must say, on multiple emerging infectious diseases and kind of tipping points, and when are we going to reach that tipping point. And it was very hard, editors didn't like it, nobody wanted to publish it, but yet here we are in this scenario of multiple emerging infectious diseases and these tipping points of climate. And I think that this planetary health, the field of planetary health, is really important, but the field of planetary health can suffer the same problems that One Health suffers from. It can become very siloed, it can become very focused, and I think that we need to look at these dynamics around connections and where are these tipping points, because they're here, they're upon us, and can we prevent them? So yeah, that's a great question, and I'm sorry I didn't include some of the planetary health stuff in my presentation. That'll be for another one. But yeah, really excited. I think it's a really, really important area of work.
Thanks. I'd like to follow up in a few minutes about some of the child stunting data. But in any case, there's another colleague has said, I'd like to hear examples of successful or potentially successful interventions to deal with some of these deleterious circles that you mentioned. Yeah, that's really interesting. It's always really nice when you can hear about what's working or what's on the horizon that may work. So have you any innovations, technological, social, political, that you can tell us about that deal with some of these circles you've spoken about?
Okay, well, yeah, thank you for that. That's a great question. Because, yeah, I really think that it's going to be technological innovation at both the micro level and the macro level that has to save us at this point. We've gone too far down these roads, and that this discourse, this continuing talking about things, that we need to have action. And it's really a shame that our little micro filters, we weren't able to distribute to households in the informal settlements, but we're still kind of working on that. But I'll give you an example of something that we've done in India for child stunting. So one of the Action Against Stunting Hub, one of the kind of outputs was to create this decision support tool. And the aim of the decision support tool, what we've managed to do is to create this model that can identify children at birth and their likelihood or their risk of stunting at 18 months old. So here we have a model, but we've made it into a decision support tool, because I think a lot of models often get lost in to identify children on the pathway to stunting, to enable policymakers and decision makers to prevent that, to stop that. So that in a way is moving into the solution space. So I think all of our projects have this kind of, at this point in time, have this real need and this urgency to move into the solution space, to try to work out solutions, to try to create technologies that are going to help. And we think that potentially this little decision support tool, which is a phone app, can transform lives 149 million stunted children. If you can predict a child who's on the pathway to stunting, you can then create more effective interventions. So, it is a lot of trial and error, but I think that we need to be much more thoughtful about what our research outputs are and how we can use them moving forward. So that's another great question. Thank you.
Thanks, Claire. Just in response to the question that was asked a few minutes ago, my colleague has written, thanks for your answer, Claire. It reminds me that the original work by Rachel Carson, Silent Spring, that
Yeah.
included, pointed to both animal and human health tipping points. This was widely read, but did not manage to restrain the growth in POPs. So, yeah, that's so just to kind of acknowledge the answer you gave, and that it kind of has resonated with my my colleague here. In terms of tipping points, I did want to ask you a little bit more about child undernutrition and tipping points. That's a really interesting concept, and I was thinking while you're speaking, I was thinking about work that was done during the COVID pandemic by the Standing Together for Nutrition Consortium. Was led by Saskia Osendorp, and they made these predictions about the impact that COVID will have on childhood undernutrition. And what struck me was it was stunting. So you talk about chronic undernutrition.
Mm.
And they predicted, I'm not sure what the timeline was, but their predictions, they had optimistic to pessimistic predictions for childhood stunting in the future were profound. And they, in that paper, I can't remember the numbers, but they put an economic value on that. And I just wanted to ask you about, like, how does one go about, or should one go about designing tipping points for childhood undernutrition? How do you go about doing that? How do you communicate that?
No, I think the work that I did was around tipping points in infectious diseases.
Yeah.
How do we, when there was a lot of work done. It was about 10 years ago, I think, where we were starting to talk about tipping points in climate. Now we know we're at them. Now we know that they're here.
Yeah.
So it was looking at kind of infectious diseases. I think when you look at child nutrition, again, it's the same kind of thing. There is EED is a really good example. There's a point of no return where you can't recover from that. You don't recover. So if you look on the individual level, there's tipping points on the individual level where we think you're on the pathway to stunting and you're not going to get off that pathway to stunting. Whereas at the macro level, at the kind of population level, you want to ensure that these children, that you've got enough children that you can support. Historically, the notion of child stunting is, well, there's nothing you can do about it.
Yeah.
And when we first started the hub, it was like, oh, there's nothing you can do about it. I was like, really? Are you serious? There's nothing you can do about it? We have to resign these 149 million children to basically a life of suffering because we can't work out what the solution space would look like for these children. So I think there are tipping points at the individual level in child nutrition. And I think that when you scale that up, you can realize that, and there's two kind of things. There's another kind of interesting thing, another interesting dynamic that's going on is this focus on individualized medicine.
Yeah.
And that was kind of what I was trying to bring to this decision support tool.
Yeah.
Individual, around the world, we're getting more and more focused by what's happening on the genomics research and everything down to the individual. We can help the individual. Well, if we can do that, then we can also identify children that are on a trajectory that we can help. So there was two kind of, rhymes or reason why we're doing that. But yeah, on the kind of global level, I really agree with Saskia because it's like we are at this, we're only now discovering what the impact of COVID had on these kids.
Yeah. It's there's a couple of things that struck me there. One is the potential of big data to inform the sort of predictive model that you just spoke about, how we predict a child who'd be at risk. So there's so much potential there. Another thing that struck me is when you spoke about you spoke about stunting and drought, and you presented some really nice data. And it kind of resonated with me with a lot of those studies that have been done from the Barker hypothesis onwards, the ones that show that particular shock, be that conflict, be it drought, be it famine. There's an intergenerational effect between maternal health and child health. And I was wondering, do you know any research that has looked at the same kind of area but with recurrent shocks? So For example, a lot of the classic research in this maternal child nutrition, as it relates to stunting as a result of maternal undernutrition, relates to specific time and place and a particular incident like a famine, etc. But with climate change, they say we're going to experience more and more shocks. Do we know anything about repeated shocks?
Well, I think one of the things that's coming out when you start identifying these areas that are at high risk of climate impacts, in a way that kind of captures this kind of repeated shock type of thing. But you're right, most research is basically you get funding to go in, you get funding to go in at that particular time point. This is another big problem in AMR research. You've really hit the nail on the head there. It's like AMR researcher, you go take one sample of a river, well, it completely changes by flow and everything else. So it's the same thing in child nutrition. I absolutely agree with you. It's like children are impacted over time, and you can almost measure that by their physicality about how that plays out. And I think that the inflammatory markers, the work that they're doing on EED and looking at how that changes over time, will really give a sense of how what that looks like. And one of the sort of clinical trials on the hub was giving symbiotic drops to infants. So for the
Yeah,
6 months of life, and it's really telling. And I don't know, this work hasn't been published yet, but I can say that one of the things is they're finding is this big impact on inflammatory biomarkers. So you can have a productive effect against future shocks. And I think that that's the way we need to look at some of this. We need to
yeah,
look at how do we know that there'll be multiple shocks, and we know that they're all going to have this the same impact on the child involved. How do we protect that child? And I think this is how we need to reorientate the work in child nutrition. We need to
that's
look
really
at it in
interesting.
a different way. Yeah.
Yeah, building almost resilience in a funny in health. There's I'll just the last comment opens out into a question, and one of my colleagues has said the problem is that we have a food production system that is not a nutrition system. And I'm a nutrition scientist working in food systems, and I always think nutrition science. I was educated in nutrition science as a health system, and nutrition is not embedded. The overlap I find between food systems and nutrition systems is not as maybe large as we often think. So I'd like you to just maybe we could end in you commenting, Claire, on in terms of nutrition systems and nutrition and health. How does it overlap with food systems? It's a big question. And the other systems. And I think if you could bring it back to this whole child approach as well, that would be really interesting.
Sure. Yeah, of course, these things, it's just exactly like the One Health issue. They're all connected. You can't really take one apart. And unfortunately, nutrition is often classified as this orphan topic. So
Yeah.
it often doesn't get the kind of funding that it needs. They're often kind of in the room. Climate change dominates nutrition, which is a direct impact. They don't really the nutritionists haven't necessarily gotten the same voice at the table. And I think this is a really big problem. So where the whole child approach came from was I looked at the literature and on kind of nutrition and child stunting, and it became really clear to me that it was very polarized. It's very kind of similar to kind of what's happening in One Health, and that it was all separate, and that there needed to be this way to link up what was happening. And so what we did was based the hub around the whole child approach, where we start with the deep biology of the child, we move to the home environment, we move to the educational environment, we move to the food systems. So we move from we move to the social dynamics and sort of social interactions at the community level. So we move from kind of the individual child cascading out across all of these different influences and putting in together this sort of very deep picture on a variety of it's quite a small population in the hub, to see if we can use this to transform the kind of the debate and on child stunting, and to help with these children. It's like I said, like these 149 million children have been very much informing our decision making in this hub. what can we do to transform their lives? So yeah, research has a heavy responsibility, but also we often have the least amount of impact. Or our impact comes 10 years later when somebody else does some amazing, terrific thing on our findings. But we still have to drive into the solution space, particularly around these big projects. So yeah, so I would say that linking and synergies is the way forward, and that if we can take One Health and move it from the particular into the more general, move it from the micro to the macro, move it from kind of identification and knowledge generation into the solution space, then I think we'll be on to a winner.
Thank you so much, Claire. There's one final comment from one of my colleagues. I was very impressed at the final slide you showed the link between child health and national GDP. I think that needs to be publicised to add to the discussion on economic development in developing countries. So the link between child health and national GDP.
Yeah, there was a very, very interesting report done by the global panel, and it's available online. I can send you the link if you want to send
That
it.
would be great. Yeah, I can share that
Yeah.
with the presentation.
Yeah, on a report that they did a few years ago, and it's a really fascinating read because it just shows you how interlinked all these things are.
That's great. Claire, thanks so much for your time today. It's been a pleasure to listen to you and for myself and my colleagues to interrogate you a little bit more. And the lovely thing is my colleagues and I are a mix of life and natural, physical science, social and political sciences. And I think there's something for everybody there. So thank you so much.
Oh, no worries. The pleasure was all mine. Thank you.
Take care. Bye-bye. Bye-bye.
I know.